Hello, my Algebra 2 students. I'm actually in the math office right now, so in case you hear any extra math going on, it might just be other teachers wandering around the room. Otherwise, what we are doing, our day 1 of Unit 6, is just going to be a quick quadratic functions review, running through all the stuff you should know from Algebra 1. So first thing, quadratic functions are just anything in the form of y equals ax squared plus bx plus c. Right? We've even looked at like the parent function already this year where it's just y equals x squared, and we'll do that again in a moment. Graphs of the quadratic function, those are known as parabolas. All right, so if we take that parent function, just plain old y equals x squared, some basics that we should know. The vertex is right here at 0, 0. So if I plug in 0, I get out 0. And then it's just having us plot a couple of different values here. So you can plug it into the calculator, or you can just simply plug the number in and square it. So -3 squared would be 9, -2 squared is 4, that should be 1, and so on. And so it's saying create a table of values, and let's sketch it just for this part right here. So we've got -1, 1, -2, 4, and -3 going all the way up to 9. Same game for the positive side of things. Okay, and then do your best to connect the dots, making a nice pretty parabola here. So when it says just sketch it over that domain, we would have no arrows. We would just have endpoints here. If it said sketch it from -infinity to +infinity, that's a different story. So we've got that part done. State the coordinates of the turning point. Turning point is the same thing as the vertex. So I already mentioned that. That guy's right at 0, 0. And then as for the axis of symmetry, this is something that should be familiar from Algebra 1. The axis of symmetry is that line that vertically splits the parabola right down the middle so that it's symmetrical on both sides. So in this case, the axis of symmetry would essentially be the y-axis. So because it's a vertical line, it's always an x equals line if we're coming up with the equation. So the y-axis is where x is equal to 0, or essentially just the y-axis there. But in terms of the equation of it, that would be x equaling 0. From Algebra 1, you might have learned that the axis of symmetry can be given by -b divided by 2a. I don't know. We'll talk about it in class. I don't teach Algebra 1, so I'm not sure. Otherwise, when it says over what interval is the function increasing, remember we're always looking at the graph from left to right. So if we're looking at it from left to right, where the graph is going to go up, that's what we're talking about here. So it should be increasing from 0 to 3. So between here and here, or like that little portion of the graph right there. That would be what we're looking at. As for the domain of what we've got here, we're looking at it from -3 to 3. And then the range, when we look bottom to top, it fits from 0 to 9. Now I chose to write it in inequality notation. Interval notation would have been fine. Set notation would have been fine. Just a quick review though. All right, when you look at the bottom, some other key details that we need to make sure that we know, right? Considering that you would have a parabola over an unrestricted domain, it should go from -infinity to +infinity. You should be able to identify the vertex, the axis of symmetry, which again, that's just that vertical line going through the vertex, and then any x or y intercepts. So we talked about that earlier in the year when we looked at the linear functions unit. We'll go over that again. But otherwise, it's saying you'll be able to figure all these values out algebraically and not just the calculator. But we are going to review some calculator steps right now. So make sure your calculator is with you when you flip on over to the next page here. So it's saying you've got the quadratic function, f of x equals -x squared plus 6x plus 5. So if you have anything in your y equals, clear it on out. Let's type this on in. Make sure you use the negative sign here. And then plus 6x plus 5. And you should be able to just probably like zoom 6 as the start. So if we type this in to y1, and we'll just go zoom 6. So if I hit zoom 6, there's our lovely little parabola. All right, so it's getting a little bit cut off, but that's okay. We'll just fix the window. So when it says use the max feature of the calculator to find the vertex, all right, to be able to locate that vertex, I want to make sure I can see the top of the parabola. So right now, I'm going to need to change my window so that I can see higher up here. So if I go and hit window, right now the Y maximum is 10. So I'm going to pick something bigger, maybe like 20, and then hit graph. And so now I can see my full parabola. So when it says use the maximum feature, remember we are doing second, trace, and then max. So if we go second, trace, choice 4 there is going to be max. And it's going to ask for a left bound, right bound, and take a guess. So a little to the left, shimmy on over to the right, come on through center, and take your best guess. So it's coming out a little bit weird on mine, but essentially it's trying to tell us that the maximum's happening at 3 and then 14. So that should be the vertex of our parabola right there. Right? When it says what's the range of the quadratic, when we think bottom to top, this parabola, even if I just give a little baby sketch, should be going all the way down, right, to negative infinity, but then up to and stopping at that vertex point. So the Y value, the highest it's going to hit is that 14 right there. So we can say from negative infinity up to and including 14, right? Or you could write it as Y is, less than or equal to 14. All right, to sketch the graph, we'll try to do this kind of quick. We can go and look at the table of functions. So we know the maximum point should be at 3 and then up to 14. So I'm just going to throw some labels on here. So there's our 3, 14. And then I can use my table to kind of fill in some of the gaps here. So at 0, it's at 5. At 1, we're up to 10. At 2, we're at 13. And then because it should be symmetrical, start coming back down. So here, here, here. And of course, if you want to go maybe one further, you can. So like at -1, it's supposed to be down at -2. And then that means at, let's see, 7. So 4, 5, 6, 7. Yeah, it should be down at -2. All right. There we go. So check. All right. Why does this parabola open downward as opposed to y equaling x squared opening upwards? This is our transformations unit. So from our transformations unit, we should know that when it's got a negative in front of the x squared, that right there is a reflection, right, over the x-axis. So hopefully you haven't forgotten everything from that. All right, and then next up, when it says between what two consecutive integers, there's the larger solution to the equation, negative x squared plus 6x plus 5 equals 0 lie, right? Well, what we've done is we've taken out f of x and put in a 0. So this is saying, like, when is the y value going to equal 0? If I'm looking at this, where y is equal to 0 is anywhere you're on the x-axis, right? So it's essentially asking for the x-intercepts, which can also be called the zeros or the roots. Any one of those words there. All right, it's where it's going to hit the x-axis. So if I just trace my x-axis here, little highlighter, make it easier to see. It's asking between what two consecutive integers. So two whole numbers that are in a row here. Does the solution lie to the equation? Let's see. If we look here, there should be one between -1 and 0. And then over here, this is between 6 and 7. So since it's asking for the larger solution, we can say that it lies between 6 and 7. Those would be the two consecutive integers right here, these guys. Okay, the very last part, when you're looking at this, is going to run through some calculator practice. It's saying you've got the equation y equals x squared minus 11x minus 26 shown below. It's got points marked at its intercepts and in its turning point, so it's vertex. So A and B are the intercepts. D is the y-intercept. Excuse me, those are x's, this is y, and then that's your vertex. So it's saying use the calculator to find all the coordinates of each. What I would like to do with you is review A, B, D, and then have you guys come up with C. So for the x-intercepts, or the 0, first things first, type into your y equals the x squared minus the 11x, and then minus 26. And then I'm going to reset that window. So if I go zoom 6, let's see, I can see part of it. I definitely can't see all of it. So I'm going to change a couple things. So my window, I want to look lower here. So my y minimum, I'm going to change that to negative 20. Let's see how much better I can see. Oh, I got some. Ooh, we really need to zoom this thing out here. All right, let me change that again. I make it a negative 30. All right, so we're going to have to keep messing with this window. Let's go and jump bigger. Let's make it like negative 60. There, we start to see the bottom of it. All right, I also need to make it wider. So in my window, let's change the X max from 10 maybe to like 30. Let's see if that'll do the trick. Okay, so in case you missed anything, my X minimum, negative 10, max is 30. So I'm looking from like negative 10 to 30. And then my Y minimum, I've got down from negative 60 up to 10, just so you can see what window I'm on here. All right. To be able to find the x-intercepts, if they happen to be nice, pretty numbers, you'll find them in the table. Otherwise, this is second, trace, and then 0. So if I walk you through that step, second, trace, 0, to go get the first x-intercept over here, slide your cursor on over. It's going to ask you to go to the left side. So in this case, that's a little bit above. So the right side, that's a little below. And then take your best guess. That should be crossing at negative 2. So the value of A right here would be negative 2, 0. That's my coordinate point there. And then you're going to do the same thing for B. So second, trace, 0. And then slide it all the way back over. So left bound, right bound, take a guess. So stay a little to the left, come above a little to the right, and then take your best guess. That should come out at 13. So that point would be 13, 0. As for the y-intercept is when the x value is 0. So you can algebraically show it by just plugging in zeros, or if you simply just hit the trace button, it usually will start you out there. Or I can go to my table and go to 0, and you can see it's going to be negative 26 right there. So there's a couple different ways to go about it. You can kind of tell this is not drawn exactly to scale, and that's perfectly fine. Right? So this one is when y equals 0, but the calculator route would be to go this way. Y-intercepts is when x equals 0. Calculator route would be to look at like the table of values. As for the last one, the turning point or the vertex, that one's on you. So see if you can run through finding that point. That's what I'm looking for as your post-video question. Thanks for watching, guys.